Welcome to HVAC with a Plant Perspective, the fourth in a series of webinars sponsored by NYSERDA and the New York Office of Cannabis Management. HVAC stands for heating, ventilation, and air conditioning. As you will learn, it can also involve dehumidification. My name is Rob Eddy, and I'll be hosting today's webinar along with my colleagues Carmen Azzaretti and Bryce Carlton, who will be the wizards behind the screen today, making all the magic happen. We welcome our New York audience back, who throughout the series has been the most curious and responsive audience to date that we have seen. We welcome those from far-flung locations outside of New York in search of non-biased information. We also give a shout out to those of you who are listening to the recording of this webinar at a time when they can be better focused on the material, which sometimes is your personal time, and we applaud your longing for education. To all of you, I can promise you will not be disappointed today by being here. Cannabis cultivation facilities are more machine than building, and require an understanding of plant physiology, engineering, and even data science. Sounds scary when I say it that way, doesn't it? But I know you're up to it. If you wanted success to be easy, you wouldn't be here. For this webinar, we sought out industry experts who not only know their stuff, but they're also really good at teaching it to beginners. You'll need to stay focused, but remember, you'll have this recording and the slide deck sent to you. So you'll be able to review it as many times as you want after the webinar. So don't panic if it doesn't all soak in right away. You'll find it more rewarding when it does, okay? Just a quick recap, or quick predictions. Our first speaker will teach you what cannabis plants need from their environment, as he says, to grow Olympic caliber cannabis plants, okay? Very exciting stuff. This is the why of what you'll learn today. Knowing the why makes the how more relevant and actually more memorable. Our second expert will discuss the New York specific regulations pertaining to HVAC, so you can stay in compliance. Most of the regulations have to do with protecting the environment, protecting your communities, so hats off to your state legislatures. Our third expert will give you a HVAC 101 lesson in plain language, promise, so you understand the concepts and the componentry. Lastly, in sort of a bonus round, we'll bring in an expert on utility incentives that can help cover a portion of the cost of your energy-saving equipment. The whole panel will take part in the Q&A session at the end, and that brings up our agenda. Carmen, if you could advance the slide. Oh, thank you. All right, so I think I pretty much spelled out what we're going to do, and there'll be a question and answer at the end, hopefully 15-20 minutes of that. Feel free to ask questions in the Q&A window or the chat window. The panel will try to get to as many of those as they can, either by writing a response or during our Q&A. Probably won't get to all of them, so apologies in advance, because again, you are a fantastic audience with a lot of curiosity. Again, a recording of today's presentation will be available after the webinar. Give us a day or two, okay? Can't do it right afterwards. There's a lot of finagling with the software. It will be emailed to all the registrants, all right? And throughout this, just a heads up, we'll be conducting polls and knowledge checks throughout the webinar, so don't be surprised if those come up. All right, let's keep going. Next slide, please. Some introductory material. Next slide. First, here's our first poll. What is the typical size room or zone that you plan to work with, okay? That you do work with or plan to? So this may not be the whole size of your whole facility, but what are the size of the rooms that you're going to be using? All right, we'll leave this question up, and you can answer when you need to. Next question, next slide, please. All right, a little bit about who we are, okay? Resource Innovation Institute is a nonprofit, objective, data-driven organization founded in 2016 in Portland, Oregon. Since 2020, we've been USDA funded and partner with the U.S. Department of Energy. The first 3 years of RII's history was focused strictly on the cannabis industry, and now we've moved into controlled environment agriculture, vertical farming, and vegetable crops, food crops, even flower crops. Our goals are to help crop producers like you through education, training, policy guidance, benchmarking, to become more resource efficient. That's what we do, resource efficiency. Let's lower the energy costs and usage. Let's lower the water consumption. Let's lower the emissions and the waste. That's what we do. And we have no other agenda than that. Next slide, please. Here's our network. We've got a lot of folks who've been doing this for a long time, and governments, the supply chain efficiency programs like we'll have at the end of today when Jay comes in, producers like yourself, and also the organizations that come up with the standards. All right, next slide, please. What we do with this network is we create industry working groups. These are a lot of fun. I host these. We get together folks from industry, from academia, from engineering firms, from local governments, utilities. We bring them all together. We distill their knowledge into a best practices guide, usually on one topic at a time, like HVAC or lighting or construction. And those will all be available to you. We'll show you those in a minute. So this is what a working group does. Those are free best practices guides. They're available to anyone. That's sponsored by the USDA and soon to be sponsored by the Department of Energy. And so that's how we can make all that free. We're not selling anything. The working groups also advocate for fair, informed policies and incentives like you'll hear about today, and regulations. By the way, if you're out there and you're not a grower, but you're an equipment provider or a vendor, if this seems like a good fit for your company, contact us about becoming a member. Love to have you. Next slide, please. Here are those best practices guides, or at least some of them. We got a whole library of them, and Carmen will put the link to the library on the chat. And so the most recent one we did was water circularity, which teaches you how to recycle your water, not just irrigation water, but all the water in your facility. And you see the other topics here, like I suggested, very, very focused: lighting, HVAC. Next slide, please. We also do benchmarking, but benchmarking is helping you measure your resource efficiency and productivity. We'll tell you what information to gather up. You'll meet with Bryce, who's really fun to work with. You'll enjoy this, and you'll take a couple hours, and by the end of it, you'll have key performance indicators telling you how resource efficient you are, how much energy you consume, how much water you consume, your water quality, your productivity, and how you rate with other growers your size. Okay, all of this again is free because of our work with in this case, with our work with New York's Office of Cannabis Management. They're the ones who make sure that's free for you. They're covering the costs. All right, you can learn more at this web page. Next slide, please. Here are today's experts. I'm excited about this. We're going to introduce ourselves briefly. I'll start. My name is Rob Eddy. I'm the Resource Efficiency Horticulturalist for RII. My background is in greenhouse management and growth room management. I spent 20 years at Purdue University managing their plant growth facilities. I also worked at Dow AgroSciences in the corporate world at their research horticulture greenhouses, and I've been a consultant for ag chem companies and vertical farms and cannabis facilities. That's who I am. I'll pass the mic to Dan. Dan, can you introduce yourself?
Sure. My name is Dan Dettmers. I spent about 25 years in the industrial refrigeration, food processing, but also processing and growing things like hops, close relative to marijuana. About 5 years ago, I moved to Quest, standalone dehumidifier manufacturer, where I was senior application engineer, and that's how many of you seen me on past RII presentations. But recently, I've moved up to the corporate ladder to Madison Air, where I'm the regulatory technical director, where I assist not just Quest, but also Madison's other companies that are familiar to cannabis culture: Argus Technology, Agronomic IQ, Addison, Big Ass Fans, and many others. And Randy.
Go ahead, Randy. Thank you. Dan.
Yeah, hi, I'm Randy Lenz. I'm with Andit. I've been with our parent company, Research Products, for 20 years. I'm working on my 21st year, and my whole time has been focused on indoor moisture control, whether it was removing moisture from residential, commercial, and agricultural spaces, or adding it back in. But that's my background has been in that. I'm currently in the Andin position as an application engineer, and I love the industry. It's a great, exciting industry, and love training people and helping people grow successfully.
Thank you, Randy. Craig?
Yeah, I'm Craig Yendrek. I'm a senior scientist with Hawthorne Gardening Company, and been growing cannabis in a R&D setting for the last 4 or 5 years. Prior to that, I spent about 10 years researching row crops at the academic level at the University of Illinois.
Excellent. Glad you're here, Craig. Jay?
Good afternoon. I'm Jay Snyder with National Grid, and I've been with National Grid for about 10 years now in the energy efficiency group. I cover most of the state for the agricultural market, and we can help out with the, anything energy efficient that you do in your facility. Thank you.
Thank you, Jay. So glad to have you here too. Next slide, please. We're probably going to look at our poll response next. Carmen, you want to take it away? I think you're muted.
I just muted and then unmuted myself. Looks like we have a pretty good spread here, with people falling kind of less so on the less than 5,000 or 500 square foot room size, and pretty evenly kind of going up into people who have some of those really large spaces, as well as people who are more towards that 750 range.
Great. Thank you, Carmen. That helps the panel know the kind of size rooms, and that informs them on sort of answers they'll give on the question and answer period. Next slide, please. Before we get into the first presentation by Craig on HVAC for plants, we'll do in the next poll. I'll read this out. What role do you play in the cultivation space? I'm not going to read these. We'll leave this up for you to answer at your convenience. I'll have Craig take it away with his presentation.
Great. Thanks, Rob. Yeah, so I'm going to dive into the physiology of plants and how environmental conditions are going to be crucial to success in an indoor grow facility. Rob started this whole webinar off by mentioning that these grow rooms are more machine than building. And one thing that he forgot to mention was how expensive those machines really are. And so the knowledge, the fundamental knowledge of plants and how they interact with their environment are super crucial to success. And the bottom line, because you're paying for those electrons that run your dehumidifiers and your lights and your HVAC systems. And so there's a lot here on this slide that growers need to be familiar with and to become expert growers. And so I've kind of broken them down into the things that are kind of easiest to more, and then as you move down the list, a little bit more complicated in terms of price. And so supplying mineral nutrients is an abiotic factor. Plants need nutrients to grow. And so anyone growing in a hydroponic system needs to be providing a complete system that provides plants with all the essential elements that they need. And that's pretty easy. There's lots of manufacturers like Hawthorne that can provide that at a pretty low cost. The second two have more to do with growth substrate, and there are really key differences that can impact your HVAC concerns based on how frequently you need to water those different substrates based on the porosity. And so won't be getting into those aspects of nutrients or substrate or even lighting, because those are all separate topics of webinars. But really where we're going to focus on is the temperature and humidity, and just emphasize for those other three aspects, nutrients, substrate, and lighting, it's great to have a resource like RII available that provides best use practices guides that give growers a real good place to start their knowledge journey and be able to help troubleshoot along the way when things come up. So use those. Make sure you're taking advantage of those. Next slide, please. So we'll dive right in with what the plants are actually doing in those indoor grow rooms and how they're influenced by the environmental conditions. And so the main function of plants is to undergo process of photosynthesis. That's how they grow. They make their own food. And so you can see here a really, really simple diagram. Plants need water, nutrients, and CO2, and they can synthesize, put together with the light, the food that they need to grow, not only the leaf material, but in the world of cannabis production, being able to fraction that carbon into the smokable flower that we all are growing the plant for. And so then I have a real fun fact there that basically says, you know, the human interaction with plants is really dependent on the oxygen output that is a byproduct of this function of photosynthesis. And so how do we, I guess, with the next slide, please. As a plant physiologist, the job we're trying to do is essentially train these plants to be high functioning. And how that's done is very, very similar to physiology in the human world. So athletes at top levels, when they undergo training, they do these Vox maximum rates of oxygenation to test how well their cardiovascular system is working. Well, I can do that same type of analysis in the grow room with some equipment for measuring the metabolism of plants. And so if you can advance the animation, please. What I'm talking about here is not putting plants on treadmills, but dedicated equipment. If you advance to the next one, that basically attaches itself or clamps over the surface of the leaf, and it can detect how much carbon dioxide that plant is taking up in that real-time, non-destructive way to be able to measure plant metabolism. And so this is super important because of those abiotic factors, to be able to diagnose issues that could potentially identify areas that you need to improve with. And so we need to adjust the temperatures, we need to adjust the light levels to be able to maximize photosynthesis. And this is a really fundamental way that can be used to do that. The other major function that's happening that really is more related to your capacity of your HVAC capabilities or capacity in the grow rooms is transpiration. And so this is a process that is needed for photosynthesis to occur. But basically it's how the plant draws water through the roots, up the stem and into the plant, leaves where photosynthesis is occurring. And what's happening there along the way is going to release an enormous amount of water vapor into the air that needs to be handled with HVAC if you're growing indoor. And so envision, I guess, the best way that I've used to explain transpiration is envision a straw or a tube of water all the way from, you know, you're pouring water or irrigating water into the substrate that's being taken up by the roots. It's a continuous stream of water that if you don't have your atmosphere adjusted properly, and if you don't have your temperature adjusted properly, you can slow that stream of water being supplied to the leaves. And what's in that stream of water in most cases is the nutrients they need to grow. And so you know, if you don't have these environmental factors dialed in properly, you're going to really have slow growth in the grow room. So if you go to the next slide, I think I kind of try to emphasize some of the problems that can exist as you change temperature, both temperature and humidity. And so, like I said before, you want to be transporting nutrients as fast as the plant's growing. And so having the proper temperature and humidity is important. And as you can see from that orange graph on the top right, you can see as your temperature increases, the rate of transpiration increases, but only to a certain point. So if the leaves get too hot, the plant is using that evaporation capacity through transpiration to cool the leaves and keep them nice and warm and happy and metabolically at their maximum. But if you reach a certain point that exceeds the cooling potential of transpiration, then you're going to start to get some damage with your plants. Likewise, with humidity, as you start to increase the humidity, that's going to slow transpiration too. So if you have rooms that are above a certain threshold, that's gonna slow things down too. And so all of this is tied together with the previous slide with photosynthesis and being able to be running your plants at their maximum capacity. And then the last point there that I have on the slide, I think is going to be covered more appropriately from the other panelists in this conversation. But based on the physiology in the room, how many plants you have in the room, what kind of substrate you're using, which determines how much you're irrigating, that all has to be paired with the capacity of your dehumidification in that grow room. And so having the right equipment really will help growers optimize the plant physiology. Next slide, please. And so you'll hear this talked about a lot more than just temperature by itself or humidity by itself. But those two factors are what is used to calculate a very important term in indoor horticulture, and that's called vapor pressure deficit. And so again, you'll hear this talked about a lot from the other panelists as well. And so I just wanted to spend a few minutes talking about what that is. It's basically how much moisture is in the air versus how much moisture it could hold at its maximum capacity. And so the difference between what's in there now and what there could be is a deficit or a difference. And that is typically measured as a pressure when we talk about it for plants, because that's what's driving that flow of water through the plant in terms of these kilopascals. And so I have a table here that's sort of general. A lot of cannabis growers are very, very specific with their VPD targets. And I just wanted to point these out as a launching point. If you haven't heard the term before, or what these different levels of vapor pressure deficit are, there's a really great university extension report that I've got linked here as a source that talks about it in much more detail. But just be aware that based on the stage that your plant is in, you may need a different VPD to maximize the growth, but also to keep the plants at their healthiest. So for example, when you're propagating, the very low VPD is required because those cuttings don't have any roots. And so their ability to be able to transpire and move water is really compromised until they start developing those new young roots during propagation. So to help the plants out, we need to keep the VPD very low, which in other words means keep the humidity high. And that keeps the environment appropriate for that stage of growth. Whereas, and I'll switch to the, sort of towards the end of the grow, where you really want your inflorescence to be filling it at the best to get the highest bud yield that you can. That's where you want to dial your VPD to a more moderate, or even some growers are using over 1.5 kilopascals to really drive transpiration, get the most nutrients up to those plants so that they bulk up and yield the highest that they possibly can based on their genetic potential. So I think I'll end it there. I think there might be one more slide until I hand it over. But this is also a really key factor to be aware of. And those are, if you don't have your VPD set appropriately in the indoor grow rooms, you can have some really serious problems that can manifest quickly. And so I've just pulled out two to give you an idea of what you might be seeing that could be possibly a VPD issue. It's hard to diagnose without some other tests or looking, firsthand. But this is an obvious first one. The leaf curling is a very well known response for cannabis to improper VPD settings. And so it could be your VPD is too low, or your temperature is too high, or you have poor irrigation management, because it's really severe curling that some people call tacoing, and that really is going to slow the growth and impact your yield negatively. And then the dreaded D word or PM word, when you don't have the proper VPD, you can get overwhelmed with powdery mildew very quickly. So if these are issues that you're seeing, that's a sign that VPD could be off, and things will need this. Different settings will need to be implemented in your facility.
Great, Craig. So we got a minute or two. I want to ask you a question. Since in controlled environment ag and in Canada's production, usually the fertilizer is in the the irrigation solution all the time, even if it's not hydroponics, even if it's growing in peat or core.
Right.
So does that mean that if you have an interruption in your irrigation at some point in time, not only you might get some short-term wilting, but could that end up leading to nutrient disorders later? And how long would it take for that to show up?
Yeah, I mean, if you do have a disruption, Rob, I think your plant is going to go down due to the lack of water. It's going to wilt and die. It's going to reach that critical wilting point and won't be able to recover from that wilt much quicker than any nutrient deficiency that would manifest. A nutrient, if you have an imbalance in your nutrient solution, it could take on the order of days to weeks to be able to see some symptoms from that. Whereas drought, your plant's could be gone in a day or two. So
yeah. Well, is there a scenario there where you would see a plant that maybe have some yellowing on the upper leaves, and that might not actually be a problem with your fertilizer? It could be that you've had some problems with your plants drying out a couple of times, not enough to kill them, but enough to dry them out.
Yeah, and that's why it's so hard to diagnose when you're not there in person. And I'll take it even one step further on the nutrient side. The best practices that you can do is if you start to see, like you described, some yellowing, clip off some of young leaf tissue, send it in for analysis, and that's really the only way that you can diagnose a nutrient deficiency, is to get a lab result, and that will definitively tell you what element might be lacking.
Right. No matter how good the pictures are you might find on the web, even if they're done by universities, you do really need a lab to really analyze it, and so you absolutely know. Thank you, Craig. That was great. I would just point out, since we got so many new growers, I want them to realize how different this is than growing in your garden, where you might put down a cow manure or 12-12 fertilizer, and then the rain comes. Those two things are kind of uncoupled. Of course, the nutrients are brought up through the water, but in this case, you're actually, if the water gets interrupted, so does your fertilizer. Also, for new growers, what Craig said about how much the water is actually used for cooling the plant and for keeping it under turgor so it's rigid. That's 90% of the water the plant is taken up is just going whoosh right out into the atmosphere. And that's why it's so hard to do HVAC inside rooms, because there's just so much water that it's something engineers, until indoor farming came about, weren't used to. So I just want to point those two things out. Carmen, can you tell us a bit about our poll?
Yeah, we have some pretty good spread here, with specifically owners and growers making up the majority of the audience. And then a handful of operations managers and consultant advisors, with equipment providers and vendors making up the smallest group. But it looks like it's pretty heavily owners and growers.
Excellent. Thank you. Next slide, please. Before we move on to Dan's presentation on the New York regulations on HVAC, we're going to do, first in history, Dan has actually done the poll question himself, so I'm going to read it. Go ahead and bring that up. Poll alert. When I say regulation, what is your first reaction? Boring? So I'm going to do the voices, Dan. Boring, complicated, boring, and complicated. Get out of my business, bro. And the fifth one is, yeah, I'm getting free help from my state government in the form of regulations designed to guide me to build an efficient and effective grow operation based on the research of the best practices from other states. The glass is half full. You can answer this question, and while Dan takes over, go ahead, Dan, and thank you for the poll.
I am hoping by the end everybody picks number 5. Because I mean, normally when I've done RI presentations in the past, I always got to do kind of the HVAC 101 that Randy's doing or something along those lines. And when Carmen asked me this time, hey Dan, do you want to do regulations? I'm like, no. Okay, I guess that's kind of my job now. So let's do this as best we can, get through it honest. There's some interesting stuff in here because as I kind of indicated in that last one, regulations, I mean, yeah, I'm not going to go through all 344 pages of it. In fact, I'm only going to cover about 1 or 2 pages out of section 125.1. But they're put there as bare minimum guidance to make sure that as you're putting together your facility, you don't make really horrible mistakes. So first off, as just quick for all those of you who are new, there's a number of different licenses and the requirements are different for different licenses. So those of you who are running small nurseries or like tier 1, which we would consider craft growers, and even tier 2, there's one set of regulations. Tier 3, tier 4, tier 5, and the RONs and the RODs, you have obviously more stringent regulations. So go ahead. Next slide, Carmen. There we go. First, not entirely HVAC, but there are odor control standards. Now, later in the section, there's actually indoor air quality regulations, but those are more for consumption lounges, places where people are actually using the product. I really like this odor control standard. It's really indoor air quality for the nursery area, for the flower room, for the growing area, for the processing facilities. Is protecting that 50% of you who are owners, 52% of you who are growers, 30 some percent that were operation managers. You know, you're living, you're working in these spaces. Make sure that you are protected yourself. And let's face it, I mean, anyone who's been around cannabis knows that there is a lot of strange smells. Mostly what we refer to those as the terpenes, the essential oils that we're trying to grow to give the flavors. There's over 100 plus of them, and all these are referred to as something we call in the indoor air quality world is volatile organic chemicals. If you would hop to the next one, Karma. These volatile organic chemicals, these are the things, these VOCs. We experience them elsewhere in life. Like you get a new car and you have that new car smell. Yeah, that's the VOCs coming out of the construction process of the car. Your new pressboard furniture, those VOCs, well, that's the off-gassing of the glues and everything that are holding it together. Likewise, some of these VOCs that are coming off of our plants, some are benign, some are not so good for us. So we want to take steps to get rid of those, to control them, and also protect our neighbors, maybe not so much from detrimental effects of the VOC, but simply the smell. In New York, California, and every state where there's been a large marijuana industry popping up, there's also been a large anti-community that doesn't like the smell of what's growing in the neighborhood. Now, on each one of these, the red italicized wording at the top, that's the actual words from the standard. So go ahead and read that while I'm talking away. I'm just simply going to comment on them. And as you can see, for removal of these odors, the technologies they list are activated carbon and vapor phase systems. These are essentially, let's call them really aggressive filters that do a great job of grabbing, capturing, and holding on to these VOCs. Some of them, like activated carbon, can be regenerated. You either heat it or use some other process to either destroy or drive the VOCs out, preferably into a outside or someplace safe. Others simply grab, hold, and you eventually have to dispose of them and replace them. But there's other options. So I have listed below also MERV 13 up to HEPA filtration. If you remember during COVID, there was a lot of talk about upgrading your furnace filters at home or at work. And they talked about MERV 13. MERV is a rating system. The higher the number, the thicker the filter and the better it is at capturing. So once you hit MERV 13, it's capable of capturing viruses, and it's also capable of capturing a lot of the stuff's coming off our plants, all the way up to HEPA. HEPA is considered the ultimate filtration. And just like active carbon, this is a capture and contain technology. The other two I have listed, ozone and photocatalytic oxidation, they're more of a destruction technology, right? So ozone is a triatomic oxygen molecule that goes off, it breaks apart, oxidizes some of these VOCs in the air and breaks them down. It's good. It gets those original chemicals out of the air, but you got to be careful because it basically creates these new chemicals that sometimes are worse than the original chemicals. So if you are doing ozone, make sure there's some sort of filtration or a way to capture it, and you don't want ozone in the air that you're breathing. Likewise, PCOs has gotten a lot of traction lately, but as I say, note, not only be careful of the byproducts, but also the reported effectiveness. A lot of people are selling these devices, but they don't give enough activation time. They don't give enough contact time with the VOCs. So your best bet is always talk to an indoor air quality specialist, talk to an engineer that's helping design your facility, talk to the manufacturer and ask for performance results, and then usually use a mix-up of all these technologies. Other standards you can look at that will be of assistance, UL 4402, yeah, that's Underwriters Laboratory, who usually is only concerned with your equipment, has put out an indoor air quality for both cultivation facilities and post-harvest. That's definitely worth a read through. It's, to my knowledge, not enforced anywhere in the US at this point, but it's just a good basic knowledge. And NFPA, the Fire Protection Association, also has a chapter on marijuana growing facilities, and there they specifically talk about outdoor air ventilation rates. Next one. So horticulture lighting gets a reference here in section B. I'm not going to go deep into it, but you can see there is minimum requirements for the energy used by your lighting. And this is important to HVAC and dehumidification because that is by far the largest heat load on our HVAC systems, right? 75 to 95% of the air conditioning load on our systems comes from those lights. I show lighting density of 25 to 50 watts per square foot. Just to give you an idea, like commercial office building, residential, a half to 2 watts per square foot is the typical range. And even at 2 watts per square foot, that's getting excessive for many. So, when you see those pictures, for those of you who haven't been in a grow facility, you see pictures of the growers and they're always wearing sunglasses. Yeah, I mean, they're cool people, but that's not the reason. It's because it's just so bright in there. They've got to wear shades to protect their eyes. Next slide. So now we get into C, the HVAC, the heating, ventilation, air conditioning, and dehumidification standards. Now, when you look around on the nationwide, cannabis is still a Schedule I substance. So you're not going to find any federal regulations that dictate and minimum energy standards for HVAC, for dehumidification. We fall back on first what we have as an industry, which for the most part is prescriptive energy requirements put out by ASHRAE, American Society Heating, Refrigeration, Air Conditioning Engineers. And those are minimum requirements on efficiency, mostly for the air conditioning equipment. There's very few standards that affect actual dehumidification equipment because for most of the HVAC world, dehumidification is an afterthought. But as our previous speaker just talked about, in the case of growing plants indoors, dehumidification is essential to getting everything out. So that's why various states like California, Colorado, Washington, Vermont, and now New York have come out with these standards to make sure that you are getting a bare minimum amount of efficiency. Because in the end, why are you getting in this business? To run it as a business, to make money. So efficiency counts because the less any money you're spending on electricity, the more profit you're going to make. So as we dig into this, hopefully you had a chance to skim through the wording on top. I want to pull out one thing that gave me a lot of heartache right in the beginning. It states that you must use HVAC and refrigeration equipment which uses a refrigerant with a 20-year global warming potential of 10 or less. Okay, global warming potential, GWP, that's if that refrigerant were to escape from our equipment and get in the upper atmosphere, this basically gives us a measure of how much global warming impact it would have on our atmosphere and on our planet. And so if you look at that table on the right, R22 was a refrigerant that came into vogue about 1995 when we phased out the original refrigerants, the CFCs. Then about 2010, we phased out R22 in favor of R410A for the air conditioning industry, a HFC, hydrofluorocarbon. The previous one, R22, was a hydrochlorofluorocarbon. Anyway, we are now in the process of phasing out R410A and moving to R454B, which is a blend of hydrofluorocarbons and HFO, hydrofluoroolefins. Don't worry, you won't be tested on all this. The important part is these HFOs have much, much lower GWPs, many below 100, some even below 10 or less. But as you can see, this blend still doesn't reach that 10 or less mark. it's still at 1,700 GWP, meaning as it stands, most 99.95% of the commercially available air conditioning equipment will not work under this rule, right? Now, okay, don't freak out. There's a loophole. I'll get to in a second. And I thank the Office of Cannabis Management. They've been working with me, especially in the last 48 hours. We've been talking this through, and they pointed out the loophole, and we're coming up with ways for you to solve this, because your only option if you want to stay below 10 GWP or less is, well, R744, which is carbon dioxide, R290 and R600A, which are respectively propane and butane, kind of explosive substances, and R717, which is ammonia. I came from the ammonia industry. I love ammonia. It's a great refrigerant, extremely efficient, wonderful to the environment. I mean, for Pete's sake, it's fertilizer, but it's very toxic and it's flammable. So I urge you, before you start looking at any of these natural refrigerants, that you make sure that you have done your due diligence, you have an engineering firm, and you have the operational expertise to run a system with that. Now, assuming you don't want to do that, next slide, here's your option. So what they have listed is, under the licensee has written, unless the licensee has a written plan for managing refrigerant leaks and disposal that has been approved by the office. So what does that mean? You need to put together a refrigerant management plan to manage the refrigerants in your equipment, to make sure that they're not leaking out, getting out into the environment, to make sure at the end of life they're disposed of properly, to make sure that your equipment is properly maintained. Now, they've given us a little bit of leeway here within there for basically the craft growers, the small ones. You have until your second license renewal to implement this plan. Now, that means 4 years, because there's 2 years per license renewal. So you have 4 years to get this implemented. For the larger growers, you have only 2 years by your first license renewal. And the Office of Cannabis Management assured me, this is what they said: the office will release additional information, including guidance, a refrigerant leakage management plan template, and instructions for obtaining approval on refrigerant leak management plans in the future. If you can't wait and you want to see what it might look like, start with the US EPA. They actually have a leak rate refrigerant management plan in place for the US. It's probably a lot less stringent than what OCM is going to require. But likewise, CARB, California Air Resources Board, has a program, as does Washington State. Now, those aren't cannabis specific, but they'll give you an idea of what a refrigerant management plan should look like. Next slide. All right, diving into some of the equipment. Under Section C, dehumidification standards, a nursery cultivator, cooperative, on and on and on, you need to use one of the following 4 pieces of equipment. The first one we have here is standalone dehumidifiers, which the definition of dehumidifier is basically, it's essentially an air conditioner in a box. I have here listed, showing a picture of a Quest standalone dehumidifier from my company and an Anden dehumidifier from Randy, our next speaker. Everything about that unit is contained within that box, which means the air coming out is going to be much drier than the air going in, and it's going to be a little bit warmer, because all the work and the energy that went into pulling that water out of the air, that becomes part of the leaving airstream. If you would hit the button, Carmen, what I want to point out is those minimum efficiencies they have listed there: 1.77 liters per kilowatt hour and 2.41 liters per kilowatt hour. They don't note the testing conditions within the standards. Well, just before we started, and again, thank you to the Office OCM and the people working there, they did reveal that they are planning on using what are basically standard conditions for consumer product dehumidifiers, the small ones, meaning that the incoming air should be at 73 degrees, 60%, and 0.2 inches external static pressure as it's tested. So this is the equivalent of when you buy a car and you get your miles per gallon. The miles per gallon are rated city and rated highway. There's a very specific test that they have to go through to get that number, so it's an apples to apples comparison. Likewise, make sure that when you're doing your apples to apples comparison on standalone dehumidifiers, that it's at these numbers. If I were to say test this at 80 degrees, 60%, 80%, or even higher, you can imagine warm, humid air coming in a dehumidifier means I'm going to get a lot more water out of it, and it's going to be much more efficient. But how many of you actually run your flower room at 80 degrees, 80%? Not many, I'm guessing. That's bedroom, that's leafy greens. All right, save that for that. But if you want to do an apples to apples comparison, make sure that you're using the same conditions. Next slide. The next piece of equipment to talk about is one, California kind of invented this term as a catch-all, integrated HVAC system. This is basically, as we're looking across the bottom, the first unit on the left is a DOAS system, dedicated outdoor air system. These are used in the HVAC industry for like supermarkets, swimming pools, other spaces where you need to bring a lot of ventilation air in, but you need to do a lot of dehumidification of that air. So you can imagine a lot of cannabis growers are using this equipment not to bring in outside air, but just simply to recirculate and dehumidify the air within their space. They will provide a decent level of cooling, but their primary purpose is to pull water out. The middle one is really the integrated HVAC system. Let's call it, I mean, really, these all have their roots in swimming pools, right? Think about swimming pools. It's another space that's primarily occupied by a large latent load, right? Take out the swimming pool, replace it with a bunch of plants, you got something that looks similar. So with these units, they've been reconstructed, refurbished, or redesigned for the cannabis industry, so that way they can provide dehumidification and cooling needs. The last one is a packaged rooftop unit, but with a hot gas reheat coil, meaning instead of this rooftop unit, this air conditioner providing just cold air, you can take some of the heat that you normally would have thrown outside and bring it back in to warm the air back up. Exactly the same as a dehumidifier does. So this is kind of like what some people would have called an all-in-one unit prior to this phrase being coined. We do see them prevalent throughout many grow operations. Basically on par, either people use split systems with standalone dehumidifiers, or a lot of times these packaged units. Again, though, check the efficiency, right? Ask them, how efficient is this going to be at my dehumidification? The other two units were made for dehumidification. This unit was kind of made for air conditioning with a little bit of dehumidification strapped on. So when you're looking at it, what's the efficiency? What's it going to cost me to operate this? Next one. All right, another option that they have out there is a chilled water system with on-site heat recovery designed to fulfill at least 75% of the annual energy for dehumidification. Why did I read that? Well, okay, a chilled water system is a chiller, something that produces cold water. That cold water goes to coil, that does the cooling of the space, that does your dehumidification. But a lot of times we got to heat the air back up. Well, here we have two different types of chillers. On the left is an air-cooled chiller, on the right is a water-cooled chiller. What's the difference? The air-cooled chiller, it rejects its heat to ambient air. So away it goes. That's how we get rid of the heat in order to cool off the water that's going to cool your space. Well, that means there is no opportunity for on-site heat recovery from that unit. That means I got to get on-site heat recovery from something else, from another room, from solar, from recovering heat from some process, maybe your extraction facility. It kind of makes it a little more difficult. What's much easier is using a water-cooled chiller, because there, as you can see, there's the red bundle and the red barrel and the black barrel. The red barrel is my condenser, so that's where the heat's getting rejected to. So it creates this hot water that normally I send to a cooling tower to reject the heat outside, but I could take that hot water and run it back around and use it to heat my spaces. So in that case, it is a great opportunity for on-site heat recovery. What's the downside of this? It's much more complicated to operate. So make sure that if this is the route you're going to do, you have the operational staff with the expertise to operate this correctly, because if not, it's going to be a huge waste of energy if you don't know how to properly operate your system. Keep it simple, right? Next slide. So the last one that they specify is desiccants. Now, I'm going to warn you, I used to sell desiccants. I used to get a commission for selling desiccants. And anytime somebody asked me, I want to put a desiccant in my grow room, I would say, why? I refuse to sell it to you until you can convince me. And the reason being, desiccant dehumidifiers, they are made for very low dew point. They're made for very cold conditions, but they are very inefficient at our normal growing conditions. At 75, 50, they're using 8 to 10 times the amount of energy that a standalone dehumidifier would use. But if you're one of those growers that wants to get down to a dew point of 30 or 25 or maybe even less, trying to get, the hues to pop, the purples, the oranges, whatever it is that you're trying to get out of there when you're stressing the plant the last couple of weeks, that's a dehumidifier may be your only option. But again, make sure that you have the actual requirement to get to a dew point of 50 degrees or less. And please try to have, for the rest of the time, have some other option for dehumidification, or you're really going to pay for it throughout your entire growth cycle. All right, next slide. So just a couple other things that were brought up that I was asked to talk about. Section D is the energy standards. This all relates to basically the prohibition of burning on-site combustion of fossil fuels, right? Now this is, you're in New York. I'm in Wisconsin. I don't know about you, but right now it's cold out here. It's, you know what? It's even colder than yesterday because your Giants beat my Packers, and it's really depressing, and everybody's upset here. Thank you very much. What was it? Danny DeVito? Who's your quarterback? Okay, never mind. I don't know where you guys found him, but congratulations. Okay, so what is this all about? What this is all about is what's a phrase called decarbonization, right? We're trying to reduce the amount of carbon basically that goes in the atmosphere that's used in the construction of our buildings and the operation of our buildings. We talk about embodied carbon reduction, which means that we're trying to reduce the carbon used for the construction of the materials, the raw materials, the raw goods, building it, and then also eventually the deconstruction, when we're taking everything back out and either recycling it or landfilling it. From the other standpoint, where we're talking about now is operational carbon reduction, where, when you burn fossil fuels on site, well, you have a smokestack, you have a chimney, out goes your exhaust, and you know what that exhaust is full of? Carbon dioxide. So therefore, the mentality is, if we move to electrification and we produce that electricity using solar, wind, nuclear, non-fossil fuel burning technologies, that's going to overall reduce our carbon impact. How do we do this? Next slide. And I think our last slide. So here's some of our options. So one is reusing those internal heat sources. So we have lights, pumps, fans that create heat in the space. That does a great job of keeping our flower room warm when they're on. But we're also fighting, don't forget, evaporative cooling from the plants, right? The more water that's coming out of those plants, the more evaporative cooling, the more heat we need to offset that. So, okay, what about when the lights are off? Well, now the technology we're looking at is heat pumps. What's a heat pump? I'll give you a hint. It's an air conditioner that runs backwards. If you look in the upper right corner, I have a schematic of the refrigeration system of an air conditioner. That indoor coil at the bottom, that's what would be inside your house. That outdoor coil would be what's sitting outside. And what's its job? It goes and it takes heat from your 70-degree house and moves to the outdoor coil where it can reject it to the hot summer day, 90-degree hot summer day. Well, in the wintertime, I simply flip this. And now I take heat from outdoors, say it's 40 degrees, I can grab heat through my outdoor coil, pump it up to a higher temperature, and now reject that heat back into my grow room, into my house, into any space I want, and actually heat the place up. I mean, it's the same thing that you're doing with the refrigerator, with the air conditioner in your car. It's just when we say air conditioning, we think cooling. When we say heat pump, it means it can go in either mode, either provide us cooling or heating depending upon which way that refrigerant's going. In the bottom left, I show an example of a geothermal heat pump. So sometimes it's air, sometimes it's the ground, sometimes it's water. Wherever that source is that we're either rejecting heat to or pulling it from. The third thing we can do is on-site heat recovery, right? So we can recover heat from exhaust air. So if you are ventilating your space, before you throw that warm air out and bring cold winter air in, run it through an energy recovery ventilator, a heat recovery ventilator, an air-to-air heat exchanger. There's any number of ways to capture some of that heat. You can recover the heat from the air conditioning, just like we talked about with that chiller, with the condenser water loop. Grab the heat instead of throwing it outside that your air conditioning is producing and put it where you need it. And that's the premise of the last one. Use heat pumps to move from warm rooms to cool rooms. So there's a couple of technologies out there, water loop heat pumps and VRF, variable refrigerant flow devices. They're basically multiple little heat pumps. And you can see in the picture I have down there below, think of it as if I had a couple flower rooms that had lights on and a couple rooms that had lights off. I have excess heat in those lights on, but I need heat in those lights off. All I simply do is either use water or refrigerant to move that heat from one room to the other. And now instead of trying to pull it from outdoors, trying to generate it with a furnace or a boiler, I'm simply removing the heat that I already have from where I don't need it to where I need it. There's lots of technologies out there. Don't be afraid. You might have to work with an engineering firm, architect in order to get this done, but there's lots of options out there. Next slide.
I think that wraps it up.
Yeah.
Thank you, Dan. That was wonderful. And like I told the audience at the beginning, you're an excellent teacher. I love the heat pump is just an air conditioner that can run backwards, and then discussing about how you can use that heat pump to, if you could stagger your rooms so that you've got some in the dark period, some in the light period, and that's another way of reducing your peak loads. So there's a lot of great solutions out there.
Well, I just love that 45% picked the last option. I'm hoping that would be up like 80% if we did the poll again from the beginning.
Yes, we'll have to try that next time. Thank you so much. We'll keep moving now. Carmen, you want to go to the next slide?
We also have another little mini poll here.
New poll here. Let's do this. I'll read this. What is the best HVAC/D, which stands for dehumidification system, for a cultivator in New York to use? This sounds like a knowledge check. Is that right? Looks like.
I think it is more of a knowledge.
Yeah, this is more of a knowledge check. Let's see how close you're listening.
It sure is.
One that meets, I'll let you read these and answer these. We'll keep moving with our presentations. Next slide, please. All right, now we're going to have our last, is there a poll for this one, Carmen? Yes, there is. And I'll read this one. We'll have two polls for you to answer. What type of topics would you like to see us do next year for 45-minute webinars? You can look at this over and answer at your convenience. So next, I want to turn it over to Randy for his presentation on HVAC 101. Looking forward to it, Randy. Take it away.
All right, and there's a lot to digest in a short amount of time, and you can see we've got a lot of experts on this panel, and that's great. That's what this RII is all about, and reaching out to us and taking advice from experts and condensing that down. So a lot of there's a lot in 15 minutes. Pretty hard to give a real hot in-depth topic conversation on HVAC 101, but it really comes down. Yeah, as Craig said, he started out talking about this was vapor pressure deficit and kind of repeating some of the same things. And that is just keeping the right vapor pressure in the room. If you had a plant that was 100% fully saturated, had 100% vapor pressure internally, and your outside of the plant was 100%, there'd be no room, no place for that water to go to. So we want to control that vapor pressure deficit and have the drier the air is outside the plant, the more it's going to pull air, just kind of like pulling water out of a sponge, just drying it out. And there's rates of doing that. You don't want to pull it too fast because you could pull up too much nutrients and damage the plant, or too slowly and not feed the plant properly or hydrate the plant properly. So there's trying to keep that and keeping things stable. Really important in cannabis to get the most out of that cannabis machine is to keep that plant at stable conditions, temperature, humidity, the lights, stability, CO2, and everything else. If you stress plants, you can stress a plant and have it lock up. It takes only about 60 seconds for the stomata in a plant to close. It can take up to 6 hours for it to reopen. So we don't want to stress the plant. We don't want to stop that machine from doing what it's supposed to do. We want to keep it going, keep it and keeping that VPD dialed in with the right temperatures, right humidity is really what keeps that machine, that plant moving forward. So next slide. We talked about this a little bit, but there are BTUs in the air. We're trying to take out either sensible BTUs, which is the temperature that we feel, or latent BTUs, which is the water in the air. With indoor agriculture being unique, that we don't really have to worry a whole lot about when we're growing indoors about the building envelope itself, because usually we're using very well insulated panels. So you're not getting a lot of, even on a hot summer day, there's not a lot of heat penetration to the building or a lot of cold in the wintertime. But with as Dan said, that lighting load is really what comes into play. Pretty much everybody has switched over to LED lighting, which has decreased it's nice because it decreased the load, the heat load, the BTUs that are going into the room. But without any downward facing heat from the light, like the plants like the sun, they want the heat coming down on them. LEDs don't have that, so you really run the rooms at higher temperature. So not only do we get less electrical bill because we don't have as much BTUs on the lights going into the space, as much heat, we can also run our rooms at a warmer temperature. And with LED, you typically do. You're running your rooms at least 5 to 10 degrees warmer than an old HPS style lighting. One of the unique things about the cannabis indoor cultivation is the daytime versus nighttime. As Dan said, looking at what the load that we have when those lights is on compared to like a normal commercial building is crazy. The amount of cooling that we have to offset the heat from the lights, the dehumidifiers, the fans, everything else in there. And then you got this huge moisture load. But then at nighttime, all that goes away. 12 hours of the day, you no longer have a heat load, but you still have a very high humidity load. And then in most cases, unless your codes locally dictate it, ventilation is pretty much kept to a minimum because we don't want to keep putting in CO2 and then just exhausting it right back outside. So we're trying to maintain proper CO2 levels, so ventilation is usually kept pretty low. So again, the largest source of heat is the lights. We want to add up those number of lights when we're going to look at the sizing of HVAC equipment. That's the biggest thing we're going to look at is how many lights do we have in that room? What is their BTUs? How long are they going to run? And that's going to tell us how much heat, how much cooling we're going to need to remove that extra BTU load, that sensible BTU load. And the dehumidifiers themselves, like we said, they reject heat in there as well as part of the dehumidification process. So we have to add all of that up. Next. And then that moisture load. This is where a lot of times people getting into the industry can run into problems. You can get the most a very good HVAC contractor, mechanical contractors who's been in the business for a long time, but most of them are not used to working with this kind of moisture load. It's ridiculous. They don't know what to do with it. They think they do, and again, that daytime nighttime load difference can really can be hard to control if you don't know what you're doing. So we're looking at that total transpiration load when we're trying to figure out how much moisture we're going to remove with the HVAC equipment and how much moisture we're going to remove with the dehumidifier. So we've talked about this. The plants are exhaling and transpiring water into the air. It's delivered up through this stomata. And then we're also looking at evapotranspiration, everything from the pot, the soil, depends what you're doing. Some people are going with dirt in a facility, doing living soil to Rockwell, to cocoa, to whatever it is, or hydroponics, and looking at that total evapotranspiration, the evaporation and the transpiration together to get the full load going into the air. We like to look at, when we're calculating this, the number of plants. Just like the lights, we need to know how many plants are in the room. What are you going to feed those plants? Water a day, how many pints per plant, liters per plant. We want to make sure we have a good calculation for runoff. We don't want to put that into our calculations. We want the runoff to go down the drain, and that's where it needs to go. We want to make sure tables are pitched and we don't have stagnant water sitting on the table. It adds to that evapotranspiration. It also can get to pest and insect problems, can create mold and mildew. So we want to make sure we get that water off of there. And it's amazing how many times you go into a grow and see wet tables with green stuff growing in them. So get them pitched. And even on the floors. I mean, it seems silly, but water standing on the floor, again, it's going to evaporate. It's going to add to your load, and you're going to pay money to take that water out. Keep your floors dry. Moving on. So Dan hit on this pretty well, but there are, we kind of categorize it into a couple different groups. There's many different, in each group, many different ways to do this. But traditionally, the industry kind of grew up on standalone air conditioning and dehumidifiers. standard air conditioning and dehumidifiers. Really in the young days of cannabis, it was 5-ton residential air conditioners. I mean, that was what was sold. Everybody was going to buy them, putting them in garages, basements, small buildings, and doing that. And that's how the industry grew up. And they grew up with, just off the shelf Menards and Home Depot type Lowe's dehumidifiers that didn't do a whole lot. So the industry has gotten better. The air conditionings have gotten better, and people are stepping up. Not using that game yet, but can step up to 10-ton, 20-ton commercial building air conditioning systems, and then using specialized dehumidifiers like Andin and Quest and others that are really built for cultivation. Along with that, there is, on top of that standard type air conditioning, there are systems with reheat. Like Dan explained, even with a heat pump or an air conditioner, technically speaking, an air conditioning doesn't really cool your space. It rejects the heat from your space outside. When you stand outside your house feeling the air conditioner, and all that warm air, that was heat that was rejected from inside your house to the outside of your house. And there are ways of taking some of that heat and rejecting it back into the space to keep the air conditioning running longer so it can dehumidify. Air conditioners really are designed to cool, to reject that heat, and as a byproduct, they will remove some water. In the residential world, that sensible heat ratio has really gotten down to about 85-15. So 85% of its energy is focused on removing the heat from the space, and only 15% of the energy of removing water from the space. And then, but there are differences by adding that heat by hot gas bypass, or just some of the rejection of the heat through a third coil. You can put some of that heat back into the space and get part of your dehumidification done that way. You'll need to oversize that air conditioning to do that. You have to add extra tonnage because it has to run longer to get rid of the heat that it rejected back in. But it does work. But typically you still need to have dehumidifiers. What we typically will see with this is you can get pretty good dehumidification, maybe all of your dehumidification with that air conditioner and reheat system during the daytime hours. But at nighttime, they can still struggle because now there's not a lot of heat to reject. When all those lights are off and you've got a room that would typically maybe only take a couple tons of cooling to cool, and you've got a 40-ton air conditioner, it doesn't have to run long to cool, so it can struggle to have enough reheat to dehumidify. So standalone dehumidifiers are typically still required, just less of them. And then, as we said, there is the all-in-one integrated systems. There's many different types of that as well. That they're larger, complicated systems. You typically don't see these in a craft world. You're seeing these in bigger MSO operations where you've got a lot of mechanical people, mechanical contractors. But that's kind of it in a nutshell. You're going to look at your dehumidification and your air conditioning and how you're going to do that. And there's pros and cons, which I'll go through next, to a little bit on each. And what you can afford. What's your upfront cost? If you're starting out as a small craft person, you probably don't have the pocketbook to go to the most advanced system, and what's going to suit your needs the best. They all work. They all work. It's just what you can afford to do, what you want to do, what your end game is there. So if we move onward. So some of the pros and cons, just from my perspective on this, is the industry grew up on air conditioning, just residential, commercial air conditioning with standalone dehumidifiers. They're reliable, they're easy to install, and easy to maintain. Pretty much any young person out of HVAC school can install any of that equipment. They can maintain it, they can operate it, replace parts on it. It gives you redundancy. If you have if you needed, say, 30 tons of cooling in a room, you put in 3 10-ton air conditioners. One of those air conditioners goes down. You go down. You lose 30% of your cooling. You can dial your lights back by 30% and still get along just fine until you can get that piece of equipment fixed. Lowest upfront cost, but the biggest downside is there's lots of pieces of equipment to maintain. A lot of dehumidifiers, a lot of air conditioning pieces. So there are a lot of pieces to control, a lot of pieces to maintain, but they're easy to control. and easy to maintain. And then when we step into with the reheat systems, it's pretty much the same. It's a little bit more complicated on the air conditioning side with the control. It just has to make sure that you have the right control message so that air conditioner continues to run and rejects the right amount of heat in, and we can maintain our cooling set point, offset some of our dehumidifier load, and then still use our standalone dehumidifiers at night, but there'll be less of them, so less dehumidifiers to do that with. Integrated system is the fewest amount of pieces, the highest cost, fewest pieces, requires a lot of mechanical contractors to operate it and or maintain it, but it can do it. It's a good equipment that is designed for that, and can remove the heating load and the cooling, the cooling load and the moisture load together in one packaged unit. Move on to the next. I know especially in New York, there's a lot of greenhouses, and greenhouses can come with their own set of challenges. People are cultivators want to grow the best quality cannabis they can, obviously, at the lowest cost, and greenhouses are very attractive that way. But it really comes out with a lot of challenges in controlling that environment, especially at different times of year. If we were close to the equator where nothing changed, we would probably be more successful. But and in New York, just like Wisconsin, we have very warm summers, very cold winters, and that can create a challenge. So typically in the daytime, during the summer months, we're going to use water walls. We're going to have some way of exchanging the air from the indoors to the outdoor, usually through that evaporative pad and exhaust, and we're pulling the air through that wall, doing evaporative cooling to cool the air, and then just exhausting the heat from the greenhouse and the humidity right out the other end. But then at nighttime, everybody's going to black out. We want to get our 12 hours of daylight and 12 hours of nighttime. You're going to black that out, and then that's where a challenge becomes. The biggest challenge is that we see controlling that temperature and humidity at night. So a lot of times when you black out, all of a sudden it's still warm in there. So we got some heat in there. And then if we turn on the dehumidifiers to try and get that humidity down so that we don't have bud rot, so we don't have pest problems, powdery mildew, we're adding more heat in what can be done. Sometimes we can do a little bit exhausting, but a lot of people don't want to open the curtains over the exhaust either and bring in any light to wake the plants back up. So we found it to be successful that it doesn't take in most greenhouses to have a lot of air conditioning during the nighttime hours to offset that heat, because it's blacked out, so you're not letting a lot of heat in from the outside. It's just heat inside that was left over from the daytime process and the dehumidifiers. So if you can put in a little bit of air conditioning, it really helps with the dehumidification, and you can really control that humidity and temperature very well at night. But then I always ask the question, we figure all that out, what are we going to do in the wintertime? Because now we've got this where we don't want to, we can't turn on our evaporative wall. It's too cold outside. So what are we going to do? And dehumidification is pretty much required 24/7 at that point. The heat from the dehumidifiers is very much welcome. It helps offset your heating costs. So what we typically will do there is kind of take a look at that total load again, and to see what is needed and what we're willing to burp out, right? Because we can burp some of that humidity out through the vents, but every time we burp the humidity, we're also burping out temperature, out the heat. We got to pay to reheat that. So having the right amount of dehumidifiers, that right relationship in there can make the greenhouse very successful in the winter months as well. So we like to take a look at all of that. We'll take a look at your daytime transpiration split versus your nighttime split to make sure that we put in the proper amount of equipment with a little bit of cooling, and be able to really successfully grow high-end cannabis in greenhouses. Next. We talked about this, kind of just wrapping up on some of my stuff here, is that just the air movement is very important. It's important for a lot of different things. We said like earlier on, the CO2 around the plant leaf is used up in about 4 minutes. Without air movement, the air around the plant almost is like a glove. It doesn't allow the temperature to get away well. It doesn't allow the cooling to get in. Humidity can kind of stack up there, and CO2 starvation right there. So you really want to have very, very good air movement. Proper air movement in a grow. You'll see the leaves fluttering. Every leaf on the plant should be fluttering a little bit, not whipping back and forth, but just moving around a little bit. And that helps with stability then in the room too, so we don't have pockets that are hot or cold or wet or dry, so that certain plants are suffering. They need more water, and other ones need less. Trying to keep that air moving, keeping good convection, using good fans, either having fans that are going in a race pattern or V-flow fans that can mix up and stir up that air to keep everything working properly, and using dehumidifiers to avoid microclimates along with that works out very well. And multi-tier racking is, everybody says it's great. I only can go so many square feet, but I can go up. So let's go up. And that has its challenges too, because it's harder to, you got to got a lot of plants, a lot of racking. It's hard to move air through that and get it equalized from top to bottom, from one side to the other. And there are duct socks. There are a lot of different ways of doing that to make sure that we're getting good air around the plant inside of all those racking systems. Next. And then maintenance. I mean, HVAC maintenance for the HVAC-D maintenance for the dehumidifiers and the air conditioning equipment is something that is very much overlooked at in the beginning stages of a build out of a grow. Budgeting for maintenance, people, parts, how are we going to do it? You scheduling downtime if you've got systems that are not redundant and you've got to eventually shut them down to do maintenance. How am I going to do that? How am I going to fit that in? Having the resources, local contractors available that can do it if it's complicated equipment, parts on hand, consumables on hand is a right way to go. There's only one guarantee with mechanical equipment: it's just going to need maintenance and it's going to break, right? So you got to be prepared for it, and the people that are prepared are the most successful. And then there's a lot of afterthought. There are HVAC equipment that's hung in above over top of the plants. There's dehumidifiers hung over the plants. How am I going to get to that equipment? What are my aisle sizes? What's my accessibility? Can I get up there with a ladder? Can I get up there with a lift to do it? Not only to just do normal maintenance. What if I had to replace something? How do I get it down? So really taking a look at how I can do that in your blueprints when you're laying out the grow is very important. And the safety. We don't want people hanging 30 foot off a ladder on one leg trying to change a filter on a dehumidifier or a piece of equipment. And next slide. So like I said, the filter maintenance is something that is done on HVAC equipment and the dehumidifiers. Filters could be looked at as a way of cleaning the air in the space, but realistically, most manufacturers are looking at keeping the equipment clean. We want to keep that air conditioning coil clean. We want to keep the dehumidifier coil clean so we don't have things growing on it and we don't get reduced airflow through it because it's got buildup. So we want to do that and replace those filters usually after every harvest, depending on what they're doing. Some people will even do it more frequently than that. Drain lines are very important as well. We don't want buildup in the drain lines of the HVAC equipment or dehumidifiers and having things back up into the room and create leaks. Schedule that routine HVAC-D maintenance as far as your KPIs. Have common parts on hand, and when spraying in a room, if you're doing any kind of defoliator or whatever you're doing to spray in the room, turn off all your equipment, turn off your dehumidifiers, turn off your AC, bag your sensors, bag your controls. Things that read humidity don't like wet water. They don't want to get wet. They like to they're reading the gas, the vapor in the air. They're not meant to read water and don't like that. So keeping those things dry. And then, once you spray in a room, it only takes seconds for that moisture to fall, and then you can turn your equipment back on. But it's common to see, filters hanging out of HVAC equipment and dehumidifiers where somebody sprayed and sucked all that water into the equipment, and it's not good for anything. So just some common sense things there. And the last note that I can leave you on is just look for industry professionals. Again, there are many, many HVAC contractors, mechanical, local, regional, that can that have been working on equipment forever, but they may have never been into this industry, and maybe their first time in a newer market like New York, and bouncing things off of us professionals on here, talking to us, and we'll give you, I don't sell HVAC equipment, but I can tell you how things will match up. If you're gonna, I'm looking at using, this type of HVAC equipment, mini splits, VRFs, chillers, whatever it is. How does that pair with the HVAC equipment, or that equipment with the dehumidification equipment, and giving you feedback on that to make everybody successful? That's what we're here for. I'm not a commissioned salesman, so I'm just here to hopefully make people grow some great cannabis that they can share with me when I come to visit.
Thanks, Randy. And we really appreciate you and Craig and Dan's dedication to just sharing knowledge, taking off the company hats and just and being putting on the industry hat. So thank you so much for that.
Yep.
Carmen, what I want to do next is let's look at the poll results. I'm going to skip this takeaway slide, and then because I really want to hear Jay and give him 10 minutes or so to talk. We still will try to squeeze in a few minutes. We'll go over a couple minutes. I don't mind doing that to answer a few questions, but you might note that Dan has been answering a lot of these questions online, and maybe now that Randy is done, he might be able to answer a few, and we'll try to get most of those answered online in the next 9 to 15 minutes. Okay. So do we have the poll results, Carmen, from Dan's presentation, or did we already cover those?
I just shared the ones about the Q5 topics. So it looks like people are really interested in insect disease prevention, as well as most energy saving design and SOPs. But there is heavy interest in all areas. Awesome.
That is great. Thank you so much. Well, I want to next turn it over to Jay on the utilities. Jay is from National Grid. As you recall from his introduction, he has a few slides on utility incentives. Jay, take it away. Take as much time as you need. Don't feel rushed. I really want them to get this information. Go ahead.
Thanks, Rob. So to begin, when people who are looking to begin the process of building a grow facility, what we run into a lot of times is they'll buy a parcel of property without the proper utilities available. So before you even go down the path of, buying a property, make sure, talk to the utilities that they have enough gas service and electric service available there before you get yourself in a pickle that you buy a piece of property that won't work for your needs. Once you determine that, it's very important you get in contact with our economic development group. We have over 20 different grants that could be available to help from the ground up build. We have brownfield development monies available. We have 3-phase power extension grants available, renewable energy, and so forth. A lot of the grants available, though, you have to apply for before any money is spent. And that is where it's very important when you guys want to begin the process to get involved, as I mentioned, because in cases we can pay for some of the engineering costs, involved, or in the case of brownfield development, the cleanup costs. So before any money is spent, we have to have that grant application opened. More information about that program can be found at the Shovel Ready site as listed on the page there. And again, we do have a whole group of people in each region. We're located Western New York, Syracuse, and Albany to cover those areas. Next. As far as energy efficiency programs, as mentioned, you've heard today of multiple different technologies that are available to meet the need of your grow facility, depending on the size or what you're trying to accomplish. And many times we have programs available to help out with incentivizing the better piece of equipment. There are building codes or energy codes involved with New York State. And what National Grid tries to do is, in a case where there is a code minimum, we try to cover 100% of the incremental cost between that baseline item and the better item. So out of your pocket, you're paying for the inefficient item, but in reality, getting the better item. So in the case of lighting, if you could buy a 1,000-watt metal halide for $100, but an LED light might be $250, we're going to try to cover that $150 incremental cost. That holds true for any type of piece of equipment where there is a code standard available. So we talked about humidification, fans, refrigeration. Not all those things have a code in place yet here in New York. So for a fan, even though there's not a code, what we would do is we would compare a less efficient fan when we would look at watts per CFM compared to the fan you would want to choose. So when you're doing your selection of equipment, always look at a few different models and look at that, watt per CFM or ton of cooling or heating per unit. And we'd want to try to compare that to something a little bit more efficient. Under the programs, back up one, please. Under there, there was a couple of questions, if I recall correctly, about geothermal and heat pumps. We've talked, Dan mentioned heat pumps, and there's a whole program, New York State program on heat pumps. In some cases, that would apply for, office type areas, common areas, things of that nature. But when we get into the more custom built rooftop VRF systems, that would go through our custom program. And again, we do have incentives for them. More information can be found on the New York State Clean Heat. If you would just Google New York State Clean Heat, there's a whole application in what is qualified under those type of pieces of equipment. In there, things that might be overlooked at times is building envelope. There is a code for insulation in the walls of a greenhouse, or if it's a truly confined space grow facility. We can look at insulation, building automation, the controls, shade curtains, and so forth. And next, we can also help out with a lot of the grow facilities I've been to are a little forward thinking, and they're always looking to for vehicle charging. So we do have programs that can incentivize up to 100% of the Make Ready, what we call the Make Ready program, which is all the power from the pole to the building, from the distribution panel back out to the charging post, not including the charging post. So if you're in a disadvantaged community, if it's open to the public, there's different rates available. And the reason I bring this up is if you're just shy of the current power at your facility and you need to do a service upgrade, if you are not to do a EV charging, that service upgrade would be at 100% of your cost to upgrade that service. But if you were to add EV charging, that service upgrade could be combined in with the EV vehicle charging, and we can help fund a portion of that service upgrade. So, it might not be something you're thinking about right out of the gate, but if you look at the big picture, if we'll help fund a portion of that upgrade, it wouldn't hurt to put in a couple EV charging stations. And I'll end with that, and we'll send it over to the Q&A.
Thank you, Jay. That was great. And great programs too. I really like the covering of the incremental cost of the equipment. That is very generous. Here's the takeaway slide. I'll cover a few of these. With proper understanding of plant metabolism, growers can manipulate temperature and RH, relative humidity, to grow Olympic caliber plants. 90% of water taken up by roots, transpired right into the air. That's what makes HVAC so tricky for plant growing. Dehumidification is based on expected maximum daily transpiration rates. Understanding vapor pressure deficit allows growers to optimize growth in various stages. You're probably going to want to change that VPD according to propagation, veg, and flower. Lighting and dehumidifiers are the major sources of sensible heat being what we feel with our skin. Transpiration is the major source of latent heat, which is the energy that's in the evaporated water in the air. Plants use CO2 around the leaf surface in just 4 minutes. So you want to keep the air moving, and bring in fresh CO2 to the leaves. The leaves should flutter a little bit. That's when you've got good air movement. You don't want them waving around like this, but you want a little bit of flutter. Actually, I can send you a video of what that flutter should look like if you contact me, and we'll have everyone's emails here when we end the show. Also, very important, don't forget this will make or break you. Budget for HVAC maintenance, parts, and labor. If you don't have the parts on hand, things will always break on Friday night or on right before the holiday. And you really also need to make sure you've got the people around who have the know-how and the time to make maintenance, to do preventive maintenance, to prepare so that you don't have disasters. We're going to jump into just a few minutes, just maybe 2 or 3 minutes of question and answer. Carmen, if you could let's leave this up. I love this. We'll do our question and answer, and you have our expert panel here and their email addresses. First one I want to start off with, and again, Randy, you don't have to spend much time answering this, but and this is a hypothetical, of course. You're getting the hard one. You're getting the cost question here. So, what's the scale for startup costs? This is a question from one of our listeners. What are you seeing on the low end, and what are you seeing on the high end? So let's just pick a size of facility, say 10,000 square foot cultivation room. Can you give us an idea, Randy, about where those prices might range from, with super simple to the highest tech?
Yeah, I don't know. Dan, you might have a better answer than me. I know. Oh, if you want to take a stab at that as well, Dan. But
no, I'll let you.
Like I said, the standard HVAC equipment and dehumidifiers are your lowest cost of HVAC equipment, and then when you go on to a fully integrated system, it's going to be a minimum of 2, if not 3 times the cost of that. So you're somewhere in between there. But it's hard to give a standard, because there's so many different pieces of HVAC equipment you can do. And if you've got 500 square foot rooms, 1,000 square foot rooms, 2,000 square foot rooms, and you're running traditional equipment or VRFs or mini splits, whatever you're running, the variability is so high.
Too complex, but I appreciate you giving a relative scale. That's an appropriate answer. Well done. I'll jump to.
I would throw in, if you're looking for dollars for air conditioning, the lowest end stuff installed, you'll probably be talking $500 to $600 a ton. Ton being a ton of refrigeration cooling potential. So think of a typical residential house as 2 to 3 tons. On the high end, you're going to be talking 1,000 to 1,500 tons for one of those chilled water systems. But that's just the HVAC. Then you're going to throw in dehumidification. Light's going to be a lot more.
And cost to install it.
Yeah.
You've got and there's sometimes that's if you've got a lot using smaller equipment, traditional dehumidifiers and air conditioners, maybe there may not cost. You can use a less skilled, let's say, contractor, but he's got a lot more hours, a lot more pieces to put in. Where the other end, you've got a very skilled person installing it, and the hours may be similar, they may be less.
Yeah, I mean, my best advice is work with professionals, work with the architect, engineer, so your plans all up front, so your costs all up front, and then get a hold of Jay and see what rebates you can get out of them for putting in the best equipment possible.
Great advice. I'll jump to one for Craig here, because Craig, working for Hawthorne and all the research he's done, may have this kind of broad perspective. This is one on solar panels. One of the questions came in on, are solar panel systems being implemented in the growing of cannabis for indoor building applications? We can pass this around, but I'll start with you, Craig.
I don't have a lot of insights. We don't see evidence of that from many of our customers, if that helps. I think it's an interesting idea, and just not familiar enough with how many solar panels you would need to provide energy for your facility.
Dan, you have any experience? I know this is outside of the realm of dehumidification and that you've been serving.
Yeah, I've seen a fair amount, and I think I threw this in the answer. A lot of times it depends upon two factors. One, if there's rebate money available to install it, that seems to drive it, and a lot of times it's both photoelectric or photovoltaic to generate electricity. But I've also seen solar thermal where you're basically absorbing heat from the sun, but you usually need to find some medium to store it in. The second one is I have seen them in people that are building operations way at the end of the grid, where it's just going to cost too much to run yet another line to get more power. So then your option becomes solar versus buying a generator and carting fuel out. A lot of people have opted for solar, I've seen.
Yeah. I'm gonna let me go back to Craig with a question I know he's probably run into or experienced. What are, Craig, for growing cannabis, what are some of the common mistakes, or maybe the most common mistake, however you want to answer that one or two common mistakes you see in growing it?
I would say, just from personal experience, the struggle we had the most with was cultural practices, the pruning, the all of the manipulations that need to happen to be able to, one, prevent disease, but also to maximize yield. There's not a whole lot of work that's been done with looking across genetic diversity, and so there's some custom approaches that need to be taken based on the genetics that you're growing. And so I think that's a really big challenge that needs a lot more attention.
Yeah, I agree. The science is only beginning. The scientific community is only beginning to, and not just at universities, but at companies like your own, is only beginning. And it's really hard. Some of these, particularly pruning techniques, it's a really hard thing to do science on. So it's still a bit of an art. So it's a good point. And Craig, I mean, Randy, I want to go back to you for this last question. Can you give us? We love at RAI. We love to hear these horror stories of things that have gone terribly wrong, because we know that's something the audience remembers. Do you have anything about HVAC that you horror stories of things that have gone dreadfully wrong with cannabis that resulted in crop loss?
Yeah, there's a lot of things like that, but it's having, that's where I get in. I love redundancy. I love redundancy in equipment. That where people, it happens. When is your HVAC going to go out? It's going to go out on Christmas Eve, and trying to get a contractor out there to fix that on Christmas Eve is hard to do. And and I warn HVAC contractors that are getting into this business, is sure something you really want to get into, because it is, it is very important. And so having those redundancies in there so that we don't go down on dehumidification, on humidification. And keeping those plants happy, keeping the heat on. Nobody really has generators, because there's power outages that can really wreak havoc as well.
Oh gosh.
And even I had a good cultivator friend of mine, just not HVAC, but where he, they work, as a cultivator, you're working 24/7, 365. You really have no time off. But this Thanksgiving, they let some people, let them go off, and hey, we're not going to work on Thanksgiving. Came in, just to check on things, and lo and behold, the timer for the lights didn't go out, and the lights stayed on all night with no plants being watered. Plants were all laying down, got everybody in, got everything hydrated, got the plants back up, but he lost 10 to 15% of his cannabis. At the end of it, the yield wasn't there, just that one stress. So it's having your ducks in a row, having sensors, having everything is Wi-Fi now, knowing what's going on in your room and be able to react to it and plan for it, because it's going to happen, right? Things break, your car breaks, everything breaks, and knowing when it breaks and trying to do the best maintenance and prevent it is the key.
I'm reminded of the story from one of the really good breeders in Denver, that they only had one HVAC unit and it went down and they lost their two rooms. And that was his big lesson, that he needed redundancy. He needed more than one unit. It has a lot of benefits, but one of it is that if you've got more than one, obviously that redundancy helps you in emergencies. So I'm glad you reminded everyone.
Oh yeah,
about
you
that.
hear crazy things where somebody, I don't have a lot of money to get started, so since there's 12 hours lights on, 12 hours lights off, I'll just use one piece of HVAC equipment and have it run each room. You know, here, oh, great idea, until that thing does not work, and then you're in trouble, and you know it's not
Yes.
a great idea. So.
Yes. Well, we're going to wrap this up. It's been a great presentation. I want to thank Dan Dettmers from Madison Air, Randy Lenz from Andon, Craig Yendrek from Hawthorne, and Jay Snyder from National Grid. For Carmen Azzaretti and Bryce Carlton, I'm Rob Eddy with Resource Innovation Institute. We want to thank the Office of Cannabis Management in NYSERDA for supporting us to present these webinars. Goodbye, everyone.